Section 4 review is about some properties of algebraic expressions, um, but it's also about what variables are. So maybe we can start with that, variables. So just to give you an example, suppose that if I have 0.6 US dollars is 1 Canadian dollar, which means that if someone wants to buy Canadian dollars with US dollars, it's going to only have to pay 60 cents in US dollars. So if I know this, how do I convert? I'd like to write a short formula for writing Canadian dollars into US dollars. How do I do that? Well, let's think about this. For instance, if I have 6 Canadian dollars, how many US dollars is that? Well, for every Canadian dollar, I get 0.6 US dollars. So if I have 6 of those, I'll get 6 times 0.6 US dollars, right? Or if you prefer, I'll have 3.6 US dollars, $3.60. I could repeat this little exercise with my favorite number. I chose 6, but any other number could have worked for creating this example. So sometimes we'll want to write down something that's unspecified. So let's say I have X Canadian dollars. So X is going to be the letter of choice when we have a quantity that's sort of unspecified. How many US dollars is that? Well, as you can see, I've replaced the X on the left by the 6 on the left by X. So I'm going to do the same on the right. It's going to be X times 0.6 US dollars. Okay. Now X times 0.6, this is where not writing the multiplication sign becomes useful. I can equivalently write this as 0.6x. You see, there's nothing that stands between the 0.6 and the x, so that means that they are multiplied. And what I have here is a formula. X Canadian dollars is equal to 0.6 x US dollars. So I've got a relationship that's useful in the sense that anyone could come and replace x by their favorite number, and they know immediately both sides of the equality. Okay. Here's an exercise for you. Another example, but it's a little exercise. You're going to convert degrees in Celsius to degrees in Fahrenheit. So I'm going to tell you what the recipe is. So to convert degrees in Celsius to degrees in Fahrenheit, which I often want to do when someone tells me the temperature of a swimming pool in Celsius. I only know what it means really in Fahrenheit, so I have to do the conversion. So the recipe is you multiply by 9/5. Okay, that's precise, 9/5. In practice, you could just multiply by 2. It's going to give you something approximate, but at least it's easier to multiply by 2 than by 9/5. But the real recipe is you multiply by 9/5 and you add 32. Okay, in practice, you could just do multiply by 2, add 32. So how would you take a temperature in Celsius, okay, and let's represent it by the variable C. So that's your temperature in Celsius, okay. How would you modify that to get your temperature in Fahrenheit? So I'd like to have it on the left an expression okay, that's equal to the temperature in Fahrenheit given the temperature in Celsius. Okay, so apply the recipe and give me the expression I would need on the left. Well, what the recipe says is you multiply your temperature in Celsius by 9/5 and you add 32. So now I have a relationship between two variables, C and F, which both represent temperatures in different units. But it's practical now. I could just replace C by my favorite number, and it shows immediately how I get the temperature in Fahrenheit. So if I would have this tattooed on my arm, right, I would never need to remember the rule. This specifies what the rule is. Of course, another good exercise would be, what if I have the temperature in Fahrenheit? How do I convert in Celsius? So what expression would show up on the left here? This is something we're gonna, the type of problem we're gonna tackle later on in the course. But if you can do that problem right away, I encourage you to do it. What else? So there's another example. You've got a rectangle with a base of length b and a height of length h. What's the perimeter? What is the perimeter for that rectangle in terms of b and h? Well, b shows up twice, right? B plus b and h plus h, which I could also write as 2b plus 2h. I'll come back to this example later on. Here's another exercise, something you'll find in the book, checking that a formula works or doesn't work. Check that a squared plus b squared is really not the same as a plus b in bracket squared. How can we check that it's not equal? Well, I could try to find or prove that it's not equal. I could try to assign values to a and b in order to show that the right hand side does not match the left hand side. So maybe I'll assume I'll be lucky. I'll just choose some random numbers. Let's substitute a by 1 and b by 2. Okay, what I'm going to do is evaluate the left hand side, evaluate the right hand side, and I'm going to check that they're not equal. If they are equal, well, maybe the expression overall isn't equal because it's just that I wasn't very lucky here. I haven't chosen the right values for a and b. Maybe there are some values of a and b where it works, but what I'm trying to, what this formula says is that it doesn't work in general. So if I'm lucky, I already have an example that shows that it doesn't work. So I'm going to evaluate. Now, if I evaluate a squared plus b squared with these values, I get 1 squared plus 2 squared. That's 1 plus 4, which is 5. If I evaluate the right hand side, I get a plus b squared, so it's 1 plus 2 squared, that's 3 squared, which is 9. And those are not equal. So it does show that this doesn't work. Here's a little question for you. In which case would it work? Like, what are there values I can assign to a and b that make it work? And in general, what are the values that I can assign to a and b that would make it work? Now the answer to that is if one of them is equal to 0, so if a is 0 or b is 0, or maybe both are 0, that's the only situation in which this is actually going to be true. Okay, so one last thing to look at, the distributive property. So in fact, this section, it says algebraic properties, but this is the only property that they actually state. So what's the distributive property? Well, you have to remember, if you have something like 7 times, I remember that's a multiplication, because I didn't write anything down in between the 7 and the bracket. 7 times 3 plus 4, so that's really the same thing as 7 times 3 plus 7 times 4. So in general, if you've got A times B plus C, the distributive property says that this is the same as AB plus AC. Coming back to my example on the perimeter of a triangle, you see 2b plus 2h. You can actually write this as 2b plus h. So I could sort of, this is called factoring the two. So I can express this sum as a product of two things. So these products, these two things, we call them factors. And when factors multiply together, they produce a product. So the product of 2n b plus h gives me 2b plus 2h. So that's kind of my distributive property applied backwards. So maybe show you other possible example. If I have minus 4 times 2x minus 7, okay. Well, what is that? That's maybe here it's easier to understand the distributive property if I have a plus sign inside the bracket. So the 2x minus 7, that's the same thing as 2x plus minus 7. So when I multiply the 4 now, the 4 is kind of like or the minus 4 is kind of like my a. In fact, it's really up to you. You can actually say that your a is the 4, and you leave the minus sign on the side for now. So this is something I like to do actually. Just consider that as my a. I'm going to distribute this over the sum, and I will keep the minus sign here. So it's 4 times 2x, 8x, 4 times minus 7, that's minus 28. I could write plus minus 28 if you prefer, like that. But ultimately it's going to give me minus 8x minus 28. And then finally I could also distribute the minus sign. The minus sign is like a minus 1, right? So it's minus 1 times 8x, so that's minus 8x. Minus 1 times minus 28, so plus 28. So it's really up to you. Of course, could be a bit faster if you distribute the minus 4 initially. So considering the minus 4 as your rate. So you see minus 4 times 2x minus 8x minus 4 times minus 7 plus 28. Okay, and then I've done it in one step. But what I wrote previously was to show you that you see when you distribute the factor that stands in front of the parentheses, you are distributing that over a sum. And if you have got a subtraction, you can convert that to subtraction into a sum in order to apply the property. So if I have maybe something like this, minus 4x minus 5y plus 6, plus 6. See, I can just distribute the minus sign. It gives me minus 4x minus 5y, that's plus 5y, minus 6, that's minus 6, like that. So if you have a negative sign in front of a bracket, it just changes the sign of every term inside the bracket. And finally, maybe something slightly more complex. Something like this. Okay. Notice I'm going to change line. Well, I could have actually, I still have a bit of space. But I can put the equality sign there, or if I change line, I put it here. It's really up to you. Now I'm going to distribute the 4. 4 times 3x, 4 times minus 8. So that's going to give me 12x minus 32. And then minus the minus 3, I'm going to distribute it, right? So minus 3 times 2x minus 6x minus 3 times minus 7, 21, like that. And then I have terms that are alike. I've got 12x minus 6x. So this is called combining like terms. So 12x minus 6x, that's 6x actually. And minus 32 plus 21, that's minus 11. So what I've done here, I've combined like terms. So right now like terms are, well, constants go with constants. So things that are not affected by variables, you combine them together. And then if you've got terms that are multiplied by x, you combine them together as well.